Hi there. So I'm going to discuss with you our topic for today, which is the internet and the WW. So the internet is also known as the World Wide Web, or we simply call it as web. So if we're going to look at the history, the internet became widespread in the 1990s and it became as one of the most important tool that we use today. It has changed the way Canadians and everybody around the world on how we learn and work, buy products and services, and how we communicate and consume entertainment. So, for instance, we use the internet for bill payments, shopping, gathering information for your school, your work, your social life. We also use the internet for file sharing, communication, and of course, I think this is most very prominent on your side, which is gaming. So let's look at what is happening before the internet. So we have the physical buildings, maybe like a mall could be seen as eBay before. You have the movie theater as YouTube. We have the library as Amazon. We have the park as Facebook. Then we have the transportation as the service provider. We have like some forums and gatherings as Twitter and so much more. And it is really fascinating that before we have the social media, they're like we stay late at night and talk about something with our friends. And for online gaming, we have the board games that we try to collaborate with other people and friends. Now, let's talk about the internet. All right, so what is an internet? Internet is an acronym for interconnected network or the internetworking. So, before we go into the details of this, let's try to look at the different jargons that we use in the internet. So, when we say network, these are two or more computers connected together. And we could actually classify this network based on the number of computers connected to it. So, if we are looking into connection of computers making use of cables within buildings, these are usually classified as local area network or we commonly call as LAN. But when it goes to a bigger uh, area or span to a geographic area, then we are referring them to as a wide area network or one. So they could be connected in terms of satellites and radio waves. So internet is of course a bigger uh, connection of computers. This will be usually described by some other books as networks of networks. So it's a worldwide networking connection of one linked by electronic and wireless and optical technologies. Actually, there is a project in 2003 that tries to map out the number of or the network of computers around the world. It was the Opte project and it was initiated by Barrett, an American entrepreneur. So if you're going to look at the diagram on the right side of the screen, so you see there are a lot of computer connected already, and there's one uh, item there, the lower bottom, that expands one of the nodes there, and you see there are a lot of connections of computers also there. So let's look at the brief history of the computer network. So as we have learned from our previous chapters, that the network was initially intended for the US military system. That was in 1950s. Then such that it evolved in 1960s that the packet switching was actually developed. In 1969, the ARPANET, or the Advanced Research Project Agency by the United States Department of Defense, have uh, like uh, went into funded research and time sharing of computers. In 1980s, the National Science Foundation standardized the TCP/IP, which is what we are using today. And in 1990, the WW, or the World Wide Web, written by Berners-Lee, was the first web browser using the HTTP, connecting all the pages written in HTML. So let's look at how the internet works. Okay, so we have the term node. Node is usually called as the redistribution point or a communication endpoint. So if we say a physical node, these are the electronic device attached to our computer network. This could be in a form of a modem, a hub, a bridge, a switch, a printer, a computer, and we are not going to discuss further what and how these are being connected to the network. It will be in your computer network classes that would give details on how this works within the network. Okay, but let's try to look at the links. Okay, so the links are the transmission media or the physical medium used to link together the nodes. So this could be in a form of electrical cable or wires, fiber optic cable, and of course the wireless, infrared, sonic, etc. And what we are mostly commonly using will be the Ethernet, which is for wired LANs, and the Wi-Fi for the wireless LANs. So how does the internet works? So you think of an internet as conversation between computers. So as we have noted in the previous slides, computers could be as individual devices, PCs, servers, or appliances. So computer will send and receive messages, which are called packet of information. So these messages could be as small as a text message or a massive as a download. Because the internet is a worldwide network, there are protocols or rules in place for the computer to communicate using a universal system. So looking at this protocol, so as mentioned in the previous slides, these are rules that allows two or more entities of communication systems to transmit information. So this defines the rule. So what do you send? In what order? The syntax, these are the format. Semantics, what does each element of the message mean? Synchronization, so what sequence? How long do you have to wait? And error recovery method. How do you know the error? How do you know that there is an error? And how are you going to recover the error? There are actually two protocols that we are using. One is the IP protocol or sorry, Internet Protocol or the IP, which is the numeric address that is known uh, in the network. So these messages are transferred between computers using packet, and a packet containing information including the destination address, data size, and data messages. Packet are routed from sender to a receiver using the receiver's IP address. And the other one is the transmission protocol, control protocol, or the TCP. This is a communication standard that enables computer to exchange messages. It provides reliability and congestion control, reducing loss of data or latency. So the IP protocol that contains the address to which the data is sent, and the TCP is the protocol responsible for delivery once the IP address has been found. So this TCP/IP is known to be the Internet Protocol Suite, which works together for you to be able to transfer data from one computer to another. Okay, so the packet routing network is a system that handles the communication between the computer. It requires the router, which is a piece of hardware that allows multiple computers to connect to one another, and that guides packet to their destination. And it uses the TCP/IP along with the IP to keep content moving reliably. So the TCP/IP works together. So there's an example here. So first, a computer A send a message to computer B IP address. The message is broken into smaller pieces called packets. Packets are sent along to the packet routing network to correct the IP address. Then four, packets are subject to transmission control protocol to maintain the quality. And number five, packet are received and reassembled in computer B IP address. So let's look at how the internet works. Okay, so usually you start by typing your address in your browser known as your URL. The router sends the packet towards the destination address. Then it connects to a modem to communicate to an ISP. Your ISP maintains the hardware and software server, allowing you to connect to other computer known as their network. Then your ISP send the message to the domain name server, and the DNS sends the page to your IP address, sending a copy of your web to your device. So we'll look into some of the terms that are mentioned here, and we're going to explain what are the differences of these networking terms in the succeeding slide. All right, so let's look at the IP address first. Okay, so please take note that there are two different versions of IP address right now prevailing in the market. One is the older version, which is the IPv4. And please take note, there are 32 bits number. This is 4.3 billion locations. And they are actually divided or grouped into four separated by dots. So each of the group there is represented by 8 bits. So you have a sample on your screen. The latest one, which was lately introduced, was the IPv6 because of the scarcity of the addresses with the IP version 4. So we are almost on the limit of utilizing all those IP addresses already. So they have introduced IPv6. Okay, so it is 128 bits. This is 3.4 times 10 to the raise of power 38 location. So you have 8 hexadecimal group of numbers. And what is very evident here is they are separated by column, and each of the group represent 16 bits. Kindly take note of this one, it's very important. All right, so these are some of the discussions about the IPv4 and IPv6. So if you're going to see, IPv4 was introduced in 1981. It was only in 1998 that IPv6 was introduced, and they coexist. Means to say, we're not yet we're not yet abandoning IPv4. It's still there, but we are also making use of the IPv6, right? Right. Okay. Nowadays. All right. So how will you know your IP address on your system? So all you need to do is go to your command prompt. Okay. On your console, type the command ipconfig, and it will show you the IP address on your computer. Okay, so there's another option here in your Windows. Right click on your network icon and select Open Network and Internet Settings, and you could just click there and see the information about your IP. All right, so there is one term that uh, it's being used nowadays. It's called the Internet of Things. Okay, so what is Internet of Things? Internet of Things, or the IoT, is a growing network of interconnected objects that can collect and exchange data in real time using embedded sensors, software, and other technologies over the internet. So they are referring to those devices that we have as object, as not merely as PC or cell phones or cars or refrigerator or vacuum. And they are able to connect these things or this object to the network. And of course, once you are connected to the network, you could control the behavior, you could program it and behave as what you have programmed. All right, so let's look at the WWW. Okay, so World Wide Web is a wide area of hyperlinked media, uh, information retrieval initiative aiming to give universal access to the large universe of a document. So there is a very good explanation here. So it talks about WW as an information system. It's a document centric. So there are a lot of documents that are there in the WW, and each of the documents are identified by the URLs, and they could be located in on the internet. So they are connected to one another or interlinked, making use of the hypertexts. All right. So how does the web work? So you use a client. So this will be the web client or your web browser to enter the URL. So the browser sends the URL to your DNS. Okay, so we'll look at what is DNS on the next slides. So the DNS returns the actual IP address to the browser. The browser establishes the TCP connection with the server, then send the HTTP GET request to the IP address received from the DNS. And the server replies by sending the HTML encoded data to your page, and the browser renders the received page. All right, so let's look at defining some of the terminologies mentioned earlier on the previous slide. So basically, we'll be looking into these terminologies one by one. So let's start with ISP. So ISP are the internet service providers. These are the businesses that we have that offers internet to consumers. All right, and we have a lot here in Canada. So I know you could name one of the different ISPs. So there are different levels or tiers of your ISP. One, or tier one, is you don't pay to move data to another network. It is a backbone. They provide the traffic to all of the ISPs. So examples here are your AT&T, Verizon, Sprint. So tier number two, network. So you must pay to transfer data to the internet network, but may be free to peer or other tier two networks. So they deliver to end customer through tier three networks. So the level three or tier three networks, so you must purchase access to the other network. It is primarily engaged in delivering internet to end users like your business and consumers network. All right, so let's look at the domain name system. So a domain name is a name for the IP address, which is easier to remember. So for the IP addresses, we have these numbers. Okay, so say for example, 208.80.154.224. So this is the IP address, for example, of a page. Okay, however, it's difficult for us to remember this number. So what do we have is a system that will associate this number to a certain name so that it would be easier for us to remember. So say for example, our Fancho Online all you need to remember is the www.functiononline.com, and not to remember the whole IP address, which is, of course, a number. Okay, so who handles the mapping of those web pages or the URLs with that number? It's actually your domain name system. So we have the top level domain. This will be usually the extension that you have to your URL address, the last one. This could be .gov, .edu, .com, .nil, .will give you uh, like the classification of the web page that you have. So let's have an example here. So the .com here is the top level domain. Example is the domain. The animals is a subdomain, and the HTTP is your protocol. So what's the difference of domain name and URL? So again, domain names, local names, path, folders, networks, locations, they are all in different syntax. So the solution is for us to unify all these things, and this is called the URL, or Uniform Resource Locator. All right. So hypertext. So what is hypertext? It's a text displayed on electronic device with reference or hyperlink to other text that the reader can immediately access. So hypertext documents are interconnected by hyperlinks. And you could actually click this one when you hover your mouse and press, for example, your screen, and it links to different objects in your system like images, videos, websites, etc. Okay, so HTTP is actually one of the protocol that we use. It's a set of rules for transferring HTML files along with computer. It is the foundation of any data exchange on the web. It is a client-server protocol, which means request is initiated by the recipient, usually your web browser, and you will query in the information to your backend, which could be written in a C Sharp or in Java. And of course, if we talk about backend, these are your databases, right? All right. And we have the HTML. So this was developed by Tim Berners-Lee, as we have noted on our previous slide. It was in 1993. So HTML contains tags. We have the opening tag and closing tags, okay, within web document. And these tags provides formatting information as well as the hyperlink information. So these are examples. Okay, so you have your opening tag there, HTML, and the end there will be the closing tags, and you could put uh, like uh, like you could format the your page making use of this tag. All right, so what is a website? Okay, so a website basically is a collection of HTML pages that um, it is published on the internet. So uh, yeah, so the current one that we use, as according to this slide, is the HTML5. Okay, so we're not going to discuss more of this one. You'll have your web page, web development class that will discuss more of your how to create a website. But basically, okay, a website, if you would like to create, you'll have to come up with HTML pages, of course. As I said, it's a collection of web pages. So usually, if you want to display something on your screen, then you'll have to create corresponding page for that. If you would like to um, make it dynamic, then you'll have to use other languages for you to be able to query in those information from the database and be able to display it on your page. Okay, so you'll need a server-side uh, programming languages like C++, Java, PHP, Python, Perl, Ruby, and what I usually use is the PHP because I think, or for me, I mean, this is what I have learned before, so I'm loving it and I'm actually continuing making use of the PHP. And your databases, usually if you use PHP, you go to MySQL as your database. So, but there are other databases like MariaDB, Microsoft SQL Server, you have Oracle, and Voldemort. Okay, so web browser, um, you are familiar with this one? So these are the applications that we use for us to view the pages, and it's not a surprising data for us that Chrome is the highest among the lists, followed by Safari. Firefox is a little bit low already. Um, Not much are using this one. So we have Edge, Opera, and so on and so forth. So as we have said, Chrome of Google is the best UI. Lots of extension, integration across devices, while Edge for Microsoft, of course, we know that uh, it's actually using the Chrome engine. All Chrome benefits are there. So much lower system and battery use, good for privacy settings. Mozilla, usually we use this one as a go-to uh, web browser because it has good in security and privacy, and it has a low system draw. So it's less compatible, but and also it has lower or support fewer extensions. Thus, we usually look for other uh, web browser. Okay, search engines. Um, we know that Google is the number one search engine that we use, followed by Bing. Then you have your Yahoo. There's the last one there, DuckDuckGo. I haven't yet actually used this one, but it has a small share of the uh, search engine that we use. All right, so HTTP, this includes the HTTP cookie are usually known as your web cookie or internet cookie or browser cookie. So it's a small data file stored on your user's computer by the web browser while you are browsing. So that when you're going to visit that site again, then you'll have that cookie being accessible once you're going to go back to that particular page. And there are three different types of cookies. You have your session cookie, persistent cookie, and you have your secured cookie. So session cookie uh, only reside in your memory when you once you are there on the website. So it disappear when when you start to leave the site. So persistent cookie, so it is time bounded, and secured cookie will be only be transmitted making use of the HTTPS. Okay, so there's a term we call buffer filtering. So a buffer filtering is a term that we use when you track your searches and other behaviors on the web. So this changes your search result based on your previous searches and how long you view the site. So according to Google and Bing, they improve the user experience by giving what they want. So their theory was if you are searching for a particular topic in the internet for this particular duration of time, most probably you're interested to look more information on those particular topics that you are searching. So what they offer in their searcher's result are those related items that you have with your previous searchers. So DuckDuckGo doesn't bubble filter according to them, but I don't know because I haven't used this one. So what do you think about the DuckDuckGo? Okay, so past and the present and the future of the web. Okay, before we have the web, we before the web, we had the internet. So basically, the infrastructure was developed first. We have the bulletin board system. We have the Gopher. We have the USNet, and everything was actually pretty much text-based. We have the email system. So until such that the American Online, a commercial system that tried to unify all above, started to decline around 2006 due to the billing dispute, corporate censorship, questionable terms of service, and the PRISM participation. It's an NSA surveillance program. So the Gopher was great until you have a share of image or formatted texts. So the AOL was inconsistent, aggressive, and with the Prism untrustworthy. So the problem was to share the CERN data and image stored in your computer with completely different computers all over the world. So there is an opportunity that they or Teams Berners-Lee saw, and he took the best idea from out of what is happening and unify it, um, and doesn't actually to worry about the backward compatibility. So there, TWW or the web was actually born in 1990s. It's actually called as the information superhighway. So there were certain personal websites that were created. Then we have the e-commerce widespread, like the web banking, Amazon, and etc. So in 2000, there was released the Web 2.0. Uh, it's a participatory web. It is a social web. It emphasizes on the user generation content, the ease of use, okay, the participation of culture in interoperability. The technology also shift from the static experience to application that are part client based, part server based. The web orientation architecture and the social web, which where the end user is part of the system, so generating content. In 2010, there is the introduction of the cloud, which is usually uh, refer to on-demand computer resources with the data storage, giving the edge in the computing power, and without the direct active management by the user. So data centers were available through the internet and web, and it pushed processing away from the client into the web. Now, the web and the society is something to think about. So, what would life would be without the web? So imagine like right now having taken away the web services and the web capabilities, what do you think will be our life? What could you no longer do without the web? What would you have to do differently? Would it be more cost more? How about in terms of time? Would it take longer? All right. Okay, so the succeeding slides talks about um, how are you going to create a web page in a high level. So of course, you'll be needing to come up with your HTML pages. So this will be the presentation part of your MVC. Um, so the content will be there, and you'll be needing CSS or the cascading style sheet. This will be the way that you're going to format your presentation or the content. And of course, the JavaScript is how are you going to do your uh, the behavior, how you're going to capture the behavior of your objects inside your pages. So say, for example, you would like to validate a value of your text box, then you'll have to use a JavaScript for that. So say, for example, you click the submit button and you would like to do some processing in there, then you'll have to use a JavaScript. So you look at the framework here. There is actually, of course, the HTML. The head will be there. The body is where you're going to put the body of your content. Okay, so we have the concept of document object model or your DOM. So DOM treats an HTML document as a tree structure where each tag of the object represent part of the document. So you have the hierarchy here on the right side of your screen. So a web browser will render the HTML document. That is, it will transform the plain text document into interactive visual representation on a user's device. Okay, so for a JavaScript, as I have told you, a JavaScript could add, change, and remove all HTML element in the page. So JavaScript will be able to control that. JavaScript could also change all the CSS style on the web page. Okay, it could react to all existing event in the web page. So say for example, if a user press enter, then you'll be able to capture that and be able to associate certain commands when the user press enter. So creates a new events within the page. So it could also trigger other events within your page. All right, so that's all for our internet and web wide web. Please just go over with the video. There's the PowerPoint presentation on your FOL, so just go through with it. And if you have questions, please don't hesitate to ask. Thank you.